So we are making an evaluation on the Gauss integral. This is sometimes known as an Euler function. So let us start and prove, because we are asked to prove this, that the integral from negative infinity to infinity of e raised to negative x squared dx is equal to root pi. Solution: let integral be named as I. Well and fine. So suppose we are having this one, negative to infinity, negative infinity, e rise to negative x squared plus y squared dy dx dy. So this means that here, because this one is I, so when we are having double integral, it means that negative infinity to infinity e raised to negative x squared plus y squared dx dy is equal to I squared. So when you plot a graph of this exponential function, it looks like this graph. The graph of such a function is equivalent to the normal distribution curve, which like this. Fx is equal to e raised to negative x squared x, like this. Now needed to find the volume of this curve. By double integration. So here we are having the following analysis. Analysis of the integration. We are having this x, y, z plane. The volume will be evaluated under x, y, z plane as follows. Now this is our tube. This is our tube. That needs to be evaluated. Okay. This one, like this one here. So we're having a volume element. Now suppose here we take, this is a tube. Suppose here we take one element. Let's use your color. Suppose here we take one element here. And we draw it aside. Like that. Having a radius r, and here it is dr, small element here. So in analyzing this element, we came to a conclusion. It becomes like that. This is our small element dr. Now taking the circumference of this, it is the same as unfolding this. It becomes 2 pi r, and here the height is the function itself, fx, which is equal to e raised to negative r squared. So now the volume of this figure becomes 2 pi r e raised to negative r squared dr. So now we have taken the case of one element. Suppose we are taking the volume of this, the entire figure up to infinity. So we are going to integrate this function sorry, yes, 0. Again, integrating this, let us substitute u in place of r. So we're having let r squared is equal to u. So 2r dr is equal to u. So we are integrating 0 to infinity 2 pi times which is equal to negative e raised to u evaluated at 0. But remember here, we are having pi 0 to infinity. Then pi times of negative e raised to negative infinity minus negative e which is equal to pi times this becomes 0 because it becomes 0 plus e raised to 0 which is equal to pi times 1 because e raised to 0 is equal to 1, so is equal to pi. However, you have said that I squared is equal to pi. Therefore, I is equal to root pi.